Lesson: Writing efficient scripts for AI model deployment. Writing efficient scripts for AI model deployment is a critical skill in the field of artificial intelligence, particularly for professionals involved in software development and data science. Effective scripting not only facilitates the seamless integration of AI models into production environments, but also ensures their scalability, maintainability, and performance. This lesson will delve into actionable insights, practical tools, and frameworks that professionals can apply directly to enhance their scripting skills for AI model deployment. One of the most important aspects of writing efficient scripts for AI deployment is understanding the deployment environment and constraints. This involves selecting the right programming language and framework that align with the deployment context. For instance, Python is a popular choice due to its versatility and the availability of powerful libraries like TensorFlow, PyTorch, and Scikit-learn. These libraries offer pre-built functions and classes that simplify the process of developing and deploying AI models. To illustrate, consider a scenario where a machine learning model needs to be integrated into a web application. Flask, a micro-web framework for Python, can be used to create a REST API that serves the model predictions. By writing a simple script using Flask, developers can expose the model's functionality as a web service, allowing other applications to interact with it over HTTP. This approach not only facilitates easy integration, but also supports scalability, as the service can be deployed on cloud platforms like AWS or Google Cloud. Another critical factor in scripting for AI deployment is the optimization of model performance and resource utilization. Efficient scripts ensure that models run quickly and do not consume excessive computational resources. Techniques such as model quantization and pruning can be employed to reduce the size and complexity of neural networks, making them more suitable for deployment in resource-constrained environments. Quantization involves converting the model's weights from floating point to integer values, which reduces memory usage and accelerates inference. Pruning, on the other hand, removes redundant neurons and connections from the network, thereby decreasing its computational footprint. For example, TensorFlow Lite is a framework specifically designed for deploying machine learning models on mobile and edge devices. It provides tools for model quantization and optimization, enabling developers to create lightweight models that run efficiently on devices with limited processing power. By incorporating TensorFlow Lite into their deployment scripts, professionals can extend the reach of their AI applications to a broader range of devices and use cases. Version control and continuous integration are additional components of efficient scripting practices. By leveraging version control systems like Git, developers can track changes to their scripts and collaborate more effectively with team members. CI tools like Jenkins or GitHub Actions can be used to automate the testing and deployment of AI models, ensuring that any changes to the codebase are automatically validated and integrated into the production environment. This continuous feedback loop helps maintain the quality and reliability of AI systems, reducing the likelihood of errors and downtime. A practical example of CI in AI deployment is the use of Docker containers to encapsulate models and their dependencies. By creating a Docker image that includes the model, its runtime environment, and any necessary libraries, developers can ensure consistent and reproducible deployments across different environments. Docker Compose can be utilized to define and run multi-container applications, streamlining the deployment process and minimizing the risk of configuration drift. Monitoring and logging are essential for maintaining the health and performance of deployed AI models. Efficient scripts should include mechanisms for capturing and analyzing metrics such as response time, throughput, and error rates. Tools like Prometheus and Grafana can be integrated into the deployment pipeline to provide real-time monitoring and visualization of these metrics. By setting up alerts and dashboards, professionals can proactively address performance issues and ensure that their AI systems operate smoothly and efficiently. Consider a case study where a financial institution deploys an AI model for fraud detection. By implementing logging and monitoring in their deployment scripts, the institution can track the model's performance and identify any anomalies in real time. This proactive approach enables them to quickly address any issues and maintain the integrity of their fraud detection system, thereby protecting their customers and reducing potential losses. Security is another critical consideration in AI model deployment. Efficient scripts must incorporate security best practices to protect the model and its data from unauthorized access and tampering. This includes implementing authentication and authorization mechanisms, encrypting data in transit and at rest, and regularly updating software dependencies to patch vulnerabilities. By following security guidelines and incorporating them into their scripts, professionals can safeguard their AI systems and maintain user trust. For instance, when deploying a machine learning model as a web service, it is crucial to use HTTPS to encrypt data transmitted between the client and the server. Additionally, employing role-based access control can restrict access to the model's functionality based on user roles, ensuring that only authorized users can interact with the service. These security measures can be seamlessly integrated into deployment scripts, providing a robust defense against potential threats. Finally, efficient scripts should be designed with maintainability and extensibility in mind. This involves writing clean, modular code that adheres to best practices and design patterns. By organizing scripts into reusable components and documenting their functionality, developers can facilitate easier maintenance and future enhancements. Tools like Pylint and Black can be used to enforce coding standards and ensure consistency across the codebase. In conclusion, writing efficient scripts for AI model deployment is a multifaceted skill that requires a deep understanding of the deployment environment, optimization techniques, version control, monitoring, security, and maintainability. By leveraging practical tools and frameworks such as Flask, TensorFlow Lite, Docker, Prometheus, and others, professionals can address real-world challenges and enhance their proficiency in this domain. Through the integration of these strategies into their scripting practices, they can ensure the successful deployment and operation of AI models in diverse environments, ultimately driving innovation and value within their organizations.